Welcome to the EPG Pathashala program, the lecture series in computer science, and this is the compiler design course 17th module where we are going to talk about canonical LR parsing. The objectives of this module are to learn to construct LR of 1 items and to learn to construct the canonical LR parsing table, to learn to parse the input string based on the canonical LR parsing table. LR of 1 items, canonical LR parsers and parsing are the keywords. Now, the reason why we have to go in for canonical LR parsers, what is the drawback with SLR parsers? SLR parsers are basically can parse unambiguous grammar, but all unambiguous grammars are not SLR parsers. Okay. So, in SLR parsers the problem is there is a shift reduce conflict which could basically arise, and that is the reason for one of the reasons for going into canonical LR parsers. Because in SLR parsers what happens is the follow information alone is based on is used for determining the reduction. So, when I say A produces alpha dot, so I normally look at the follow of the LHS non-terminal which happens to be A in our case, and at the intersection of that item number and the follow of A, I mark the reduction by A produces alpha. But what happens is that information alone is not sufficient to decide when to reduce. That is the reason for this conflict in SLR parsers. So, we need a more powerful parser which is going to overcome this shift reduce conflict available here. So, in SLR if there is a production of the form A produces alpha dot, then a reduce action takes place based on the follow of A. There would be situations where when state I appears on the top of the stack, the viable prefix beta alpha on the stack is such that beta A cannot be followed by the terminal A in a right sentential form. So, this is exactly what is the problem. So, you have the state I on the stack and the prefix beta alpha is there, and beta A, that is I cannot replace this alpha with A, and if I replace I will not have A in the right sentential form, that is the reason. Hence, the reduction A produces alpha would be invalid on input terminal being A. So, that is the requirement for the CALR parsers, where the motivation happens to be if it is possible to do more in the states that allow us to rule out some of the invalid reduction, we will be in a position to have a better parser design. So, here what we do is we introduce more states as compared to SLR parsers, introduce exactly which input symbols to follow a particular non-terminal is also decided. Okay. So, here the reduction is not based upon the follow, but the input symbol is actually stated explicitly in the item itself. Okay. So, here the first step in CALR parsers is you have to construct LR of 1 items. So, where we had LR of 0 items in the SLR parser, here we have what is called as canonical LR, which is LR of 1 items, and use these items to construct the canonical LR parsing table, which is going to be involving the action go to etc., and use this parsing table along with the input string to parse the string based upon the stack. So, the motivation is extra symbol is incorporated in the item to include a terminal symbol as a second component, and for example, here A produces alpha dot beta comma A. Now, what is the situation here is where A produces alpha beta as a production and A is a terminal, or the right hand marker dollar is used, and this is referred to as an LR of 1 item. So, where you had alpha dot beta alone, here what happens is A produces alpha dot beta is also incorporated along with a terminal A, and this terminal A indicates it is going to be the right hand marker, or it can be also a dollar. Okay. So, this is refers to as the LR of 1 item. So, the 1 here refers to the length of the second component, which is typically called as the look ahead of the item. Now, the LR again it is the same representation. L is input string is scanned from left to right, R is incorporating rightmost derivation, and here 1 means I am look ahead of 1 of length 1. Okay. So, look ahead has no effect in a production of the form A produces alpha dot beta comma A, where beta is not epsilon, but if A produces alpha dot comma A, and this calls for a reduction by A produces alpha, and this will be done at the intersection of A comma that item number as against the follow of A. Now, if I have some beta present here, then this A is not a big botheration. Only in the scenarios where I have a dot at the end, only if I have a dot at the end, I will be in a position to reduce it with the production. A produces alpha, only there this input symbol A is going to play a major role. So, let us just consider this. Supposing you have A produces alpha dot beta comma A is a valid item for a viable prefix gamma, okay, and if there is a derivation of the form, so S derives delta AW, which in turn will derive delta alpha beta W. That is, here A is, it's a right sentential form, right derivation, therefore W is replaced, and then I have this A getting replaced with alpha beta because I have a production in the form A produces alpha beta, and here gamma is equal to delta alpha, okay, and either A is the first symbol of W or W is epsilon and A is going to be dollar. This is going to be the interpretation of LR of one item. Let us look at the LR of one item algorithm. Again, it involves closure, go to, and item set construction. Okay. So, closure of I is first basically called, and you have to first do closure of I, and you have to repeat for each item of the form A produces alpha dot beta comma A present in item number I. I have to, and for each production B produces gamma in G dash, okay, and each terminal B in first of beta A, that is after the dot whatever I have here along with the terminal A. So, I have to look at the first of beta A here such that B produces dot gamma comma B is not in I, do add this item to the item number, okay. So, what is the situation? I have to look at the dot, okay, that is going to be before a symbol beta. So, if that beta begins with the capital B, okay, I have to add, supposing if this B produces gamma, I have to look at this first of beta A. First of beta A is considered, and supposing say you have the first of beta A as some terminal B. You have to add the production into the item B produces dot gamma comma B. If it is not in I, add it, okay, until no more items can be added to I. So, this is what is your situation. Now, exactly what was told in the earlier SLR parser LR of 0 item, only reason being you simply kept on adding this closure of I without looking at this A, okay, and so therefore, this first of beta A was actually not considered at all. So, the closure is exactly similar, only the reason being I will be including the symbol B here as against the non-availability of that symbol in LR of 0 items. Again, this calls for determining go to. So, go to will be, let J be the set of items of the form A produces alpha x dot beta comma A such that alpha dot x beta comma A is in I. So, you have the production, for example, A produces alpha dot x beta comma A present in an item I, go to of I comma x, that is a dot appearing before the symbol x. I have to shift the dot by one position to the right, and then what I should do, similar to I have to compute closure of this beta, okay. So, again I have to look at beta A. If this beta begins with the non-terminal, I have to return its closure. So, this is exactly similar, only difference being I have to add the extra component A to your item construction. Items G dash, I will start with closure, okay, add the first production with the dollar, okay. So, this is how I start, and then for repeat for each set of items I in C and for each grammar symbol X such that go to of I comma X is not empty and not in C, okay, until you have to keep on adding until this go to is going to be available, and it is going to be and the item is not already available in the closure C, and go to of I comma C X to C, and until no more set of items can be added to C. So, again this calls for item set construction, calls for determining closure and determining your go to. Now, this closure will be starting with the first production, that is of the augmented grammar with a dollar as the end marker. Now, after this anyway I have to add the productions of S. After the productions of S are going to be added with a dollar at the end marker, I have to then start going with the go to construction, that will be your total item set, okay. So, let us say that you have the grammar S produces capital C, C produces C capital C and C produces D. Let us say the augmented grammar will be S dash produces S, S produces C and C produces small c capital C and C produces D. So, the same grammar is added with the initial production alone being different. So, I naught. So, I naught will start with S dash produces dot S with a dollar at the end. Now, I have to add the productions of S. Okay. Now, this is my beta, alpha dot beta comma A. This is my beta. First of S dollar will be considered. First of S will be, if you remember, S produces capital C only. So, this will be first of C comma D. It will be first of C, which is nothing but C comma D. Okay. So, here S produces dot CC will be added with a dollar, and C produces dot C capital C, that is for this particular condition. Okay. See, alpha dot beta. So, if you look at the algorithm here, the algorithm will have alpha x dot beta, okay, and I have to look at first of beta A. So, after the dot, whatever symbol is available, I have to look at first of beta A. So, if you look at that as your situation, so this is going to be your condition where I will be adding first of S dollar, okay, sorry, alpha dot B beta. So, beta will be after this basically. So, this is your capital B. So, S is your capital B and this is your beta is epsilon here and this is your A. So, first of dollar will be only dollar. So, I have to add dot CC. Now, again I have alpha dot B beta. So, this B will be capital C, beta is capital C and this is your A. So, C is your beta. So, first of C dollar will be C slash D. So, which is nothing but I have to add the productions of C with the A component as either C or D. So, I am combining here two items together where it differs only by the last component C slash C or D. Similarly, I have to add the productions of C produces dot D with a C slash D. Now, this is my item set. So, here I have alpha dot B beta. So, look at beta A's production. So, beta is epsilon here, therefore, this is dollar. Next one, B is capital C, this B is capital C, beta is capital C. So, beta A's first is going to be C slash D. That is what I have got here. Now, I naught comma S will be shifting the dot by one position to the right and having the dollar as it is. So, S dash produces S dot comma dollar. And I2 will be go to of I naught comma C, okay. So, here, so this is going to be shifting the dot by one position to the right. Now, this is again my B, beta is again epsilon, dollar is here. So, first of beta A will be dollar only. So, add the productions of C with a dollar at the end marker, okay. Look ahead symbol basically. And then I3 will be go to of I naught comma small c, and which is nothing but shifting the dot by one position to the right. So, C dot C comma C slash D, because it is the same thing what is available here. Now, this is my capital B, beta is epsilon, A is again C slash D. So, I have to add the productions of capital C with a C slash D as your end marker. So, C produces dot CC comma C slash D, C produces dot D comma C slash D. So, I4 will be go to of I naught comma D, which is again C produces D dot comma C slash D, and I5 will be, so I am done with I naught. So, I1 there is nothing, I2 will be go to of I2 comma capital C. So, go to of I2 comma capital C will be shifting the dot by one position with a dollar here. So, this is done. Then I2 comma small c will be shifting the dot by one position in I2. So, I2 has got here with a dollar as the end marker. So, I shift that by one position and results in C dot C comma dollar. Again, now this is B, beta is epsilon, dollar is going to be available here as an A. So, I have to look at the productions of C with a dollar as the look ahead symbol. So, dot CC comma dollar and dot D comma dollar. So, similarly proceeding, I7 will be go to of I2 comma D. Now, this I7 and I4 are different. I4 has a look ahead as C slash D, I7 has a look ahead as dollar, okay. I8 has a look ahead of C slash D, I9 has a look ahead of dollar, the item remains the same, but still it is considered as different item only because the look ahead is going to be different. Okay, so this is the advantage of canonical LR parser. It is resulting in so many number of items, which is going to be result in having a powerful parser here. Okay, so after constructing the item set, now I have to construct the parsing table. The parsing table will be again similar to the SLR parsing table, where the rows will correspond to the item numbers and the columns would correspond to the terminals and the non-terminals, where I will group the terminals as action, group the non-terminals as go to. So I construct the item set LR of one items I0 to IN, and state I of the parser is from II. If A produces alpha dot A beta comma B is in II and go to of II comma A is equal to IJ, then you have the action I comma A is equal to shift J. That is, you are having a dot in the middle. Okay. So look at the go tos alone. For a terminal, you set the action I comma A is equal to shift by J, where A is a terminal. Similarly, if this is going to be an end marker, alpha dot is available, here there is no need for determining the follow and all. A follow is not required here because I am incorporating the follow information itself as a look ahead symbol in the items itself. So this is my look ahead, A is my look ahead here. If I have a production item with a dot at the end, then in that item number II, where this A is not equal to S dash, that is, it should not be the augmented production. So you set the action I comma A is equal to reduce by A produces alpha. Okay. So this is the A we are talking about here. If this A has got multiple symbols, as in our example C slash D, at the intersection of I comma C and I comma D, I add the entry reduce by A produces alpha. And the next one is a conflict here implies that the grammar is not a canonical LR grammar. So here if it has a conflict, then I cannot handle it at all. That is what you are trying to look at here. And if go to of II comma A is equal to IJ, I am looking at the non-terminal alone here. Then at the intersection of I comma A, you simply add the component J. Okay. So from the item number II on A, if it goes to IJ, then go to of I comma A will be only J. And the last one, it implies an accept action. Okay, that is at the intersection of S dash produces dot S comma dollar implies an accept action. So which item number you have at the intersection of I comma dollar, you add the action as accept. All other entries are going to be error. So this is similar. Only difference between this and the SLR parser is you are not looking at the follow. You are looking at the look ahead symbol itself to decide on where to put the reduce action at the intersection of the item number against what terminal you should basically use. That is available here itself in the item number itself. All other things are exactly similar to what SLR parser typically did. So let us look at the parsing table here. So here we had I0 comma C is I3. So I am calling this as S3. I0 comma D is I4. So I am calling it as S4. Okay. So just a quick go through on what we look at here. So I0 comma S is I1, I0 comma C is I2, and I0 comma small c is I3, I0 comma D is I4. Similarly, I2 comma C is I5, I2 comma small c is I6, so is I6 comma C. Okay. So that is what is indicated in the parsing table. The parsing table basically says 0 comma C, I0 comma C went to I3. So at the intersection of 0 comma C I have S3, intersection of 0 comma D I have S4, 0 comma S is 1, 0 comma C is 2. So I1 there is nothing because it is S dash produces S dot termination. So I2 comma C is S6, I2 comma D is S7, and so is I3 comma C is S3, I3 comma D is also S4, and I6 comma C is S6 and I6 comma D is S7. Similarly, I0, I6 comma capital C is 9, I3 comma capital C is 8. Now on to the reduce action, you know that the first one has a accept action available here, and if you remember we had a component at I4, okay, you had C produces D dot, okay, C produces D dot is available at I4 at the intersection of C slash D, that is your look ahead. So at the intersection of 4 comma C and 4 comma D, I add the reduce action as R3. Similarly, at I5, you had S produces CC dot slash comma dollar. So at the intersection of 5 and dollar, you add reduction as reduced by R1. And similarly, with respect to state 7, at the intersection of 7 comma 7, you had the production C produces D dot comma look ahead being a dollar. So you had that here, and at the intersection of I8, you had the reduction C produces small c capital C with a look ahead as C slash D. So at the intersection of 8 comma C and 8 comma D, you add R2, and at the intersection of 9 comma dollar, you had R2 again, because I9 will basically be C produces small c capital C with a dollar as the look ahead. So this is what you have basically done. So parsing table is exactly similar to the previous SLR parsing table only. The only difference being that you will not compute follow, rather you will use the look ahead available in the item itself to try to look at the parsing action, or to construct the parsing table basically. Now after constructing the parsing table, you can now go at the parsing algorithm. The parsing algorithm is also exactly same. You will use the input symbol, input string, you will use a stack, and you will use the parsing table which is being constructed. So if there is a dollar at the end marker of the input string, and let S be the state on top of the stack, and let A be the symbol pointed to by the input pointer, and if the action is a shift action, you push A and then you push this S dash on top of the stack. If it is reduced, you pop twice beta symbols, where beta is your RHS of the production, and now you will also push S dash onto the stack, which is already on the stack. You will push capital A onto the stack, and you will compute go to of S dash comma A and put that also on the stack. If the action is an accept action, you will basically return, else it is going to be an error action. So let us just look at this here. Consider a string CCDD dollar. So 0 comma C, it says shift by 3, S3. I shifted C and 3 onto the stack. Again 3 comma C, shift again 3. So C and 3 is shifted onto the stack. Then 3 comma D is shift by 4. So I will shift D comma 4 onto the stack. And then 4 comma D is reduced by 3. So I pop 2 symbols from the stack. That leaves you with a 3 on the stack. Push capital C on the stack. So 3 comma C is H. So I have pushed that also onto the stack. Again 8 comma D, same action, reduced by second production. So which is C produces small c capital C. So pop 4 symbols. So that will leave you with a 3 on the stack. So 3 comma C is H. Okay. You push 8 onto the stack. Before that, push the capital C onto the stack. So again 8 comma D, reduced by 2. So pop 4 symbols and go to this particular state. So 2 comma D is shift by 7. Okay, 2 comma D is shift by 7. So you shifted D and 7 onto the stack. There is a dollar available here. 7 comma dollar, reduce 3, reduced by the third production, which means popping 2 symbols of the stack and computing go to of 2 comma C, which is nothing but 5. So C5 is pushed on the stack. Exactly the same logic as your SLR parser. Only thing is you will have to refer to a different parsing table. Okay, that's it. So dollar 5 comma dollar will be reduced by 1 and pop 4 symbols of the stack. So go to of 0 comma S is equal to 1, and finally 0 S 1 is there, 1 and dollar accept, therefore successful parsing. So this is about canonical LR parsers. So let us just take this example which we discussed in SLR parser, where we had a shift reduce conflict there, and now this canonical LR parser is a powerful parser. So there should not be any conflict here. That's what we are trying to understand. Okay. Again, let us look at the same production. The grammar is augmented with S dash produces S. This is your productions, R produces L. Now this is I naught. So I naught here will be a dot to start with. Alpha is epsilon, dot B is here, beta is also epsilon. So epsilon first of beta A. So which is nothing but again dollar. So add the productions of S with look ahead as dollar. So dot L equal to R dot R. Okay. And then you compute L is there. So this is B, beta is equal to R, A is dollar. So first of beta A will be equal to, okay. So you basically put equal to here with a dot star R, L produces dot star R, comma equal to. And then here you have L produces dot ID, it's again going to be equal to slash dollar. So, and then finally R produces dot L. So, R produces dot L, the beta is only dollar, so I have dollar here as a symbol. Now, after this I have to find out now I naught comma S. I naught comma S, I am calling it as I1, shifting the dot by one position to the right. Then I have I2, which is nothing but I naught comma L, shifting the dot by one position to the right in this particular production, and I have one more here which is R produces L dot comma dollar. Then I3 will be I naught comma R, shifting the dot by one position in this particular production, S produces R dot comma dollar. I4 will be go to of I naught comma star. So I naught comma star will be here. So I have it available here. So L produces star, shifting the dot by one position to the right, L produces star dot R, comma equal to slash dollar is here, that is available here also. And then R produces, so now I have a R here, so R produces dot L with the same look ahead, L produces dot star R again with the same look ahead, L produces dot ID again with the same look ahead. Now after this I am done with I1, I naught is over anyway, I am done with I1, I am done with I2, I2 comma equal to is there, okay. So, but here I5 will be L produces ID dot comma equal to slash dollar. I am done with I1, I naught and I2 I have to look at as I2 comma equal to. I2 comma equal to will be different because it's S produces L equal to dot R. So, I2 comma is equal to is pending, which I am calling it as I6, and here I have I3, nothing is there. Here I have I4 comma R is I7, I4 comma L is I8, I4 comma star is again I4, I4 comma ID is I5. Okay. So, here I6 will be shifting the dot by one position to the right here, and then I have to add productions of R, again look ahead is only dollar, productions of L, look ahead is again dollar, okay. So, this is I6, I7 will be already done, L produces star R dot, I8 is already also done, R produces L dot, and I9 is S produces L equal to R dot comma dollar. Now, I am done with I5. So, I6 comma R is I4 again, I6 comma L is I10. So, shifting the dot by one position to the right, and then I6 comma star is I11. Now, I6 comma star is I11. What's the previous one? I4 comma star is I4. So, it's different because this has got a equal to slash dollar, that will have only a dollar. So, here I6 comma star is I11, star dot R. So, I have a sequence of items here which is just the same thing, but with the dollar as the end marker, okay. And then I have here I9, I10 is done, I11 comma R is I13, I11 comma L is I10 itself, here I11 comma star is I11 itself, and I11 comma ID is I12. So, I12, I13 has to be discussed here, which is I12 is L produces ID dot comma dollar, and I13 is L produces star R dot comma dollar. So, the parsing table exactly similar, okay, where we have expressed the reduction, and as you could see there is no shift reduce conflict here, okay. So, just to give a quick overview, I13 has got a dot at the end. So, at the intersection of 13 comma dollar, I will add this production reduced by this one. So, just to give a recap, 13 comma dollar, I will have R4. So, this table does not have any conflict at all. Since there is no conflict, it is easy to parse using the canonical LR parser. So, canonical LR parser is the most powerful parser. And it is, but the drawback of this parser will be having lot of item numbers as compared to the other parsers. Okay, the SLR parser has got lesser number of items, whereas CALR parser has got more number of items. So, it has so many items and states, but there is no conflict at all if the grammar is a unambiguous grammar. Okay, thank you.